We talked about a little bit about QO-100. QO-100 is our geostationary satellite, launched by, designed by AMSAT Germany, and launched by United Arab Emirates. It's a commercial satellite called SAL2, but on board there is an amateur radio payload. It all started with a meeting at the amateur radio convention in the UAE, when somebody from the UAE Radio Society came up to Peter Gilwell and said, wouldn't it be good if you could actually put a amateur satellite on a commercial satellite? Peter went, whose hand do what do I do? And they said, we want to do it. Okay. Which then led on to a Mitsubishi developed satellite called SL2 carrying an amateur radio payload. Mitsubishi had never designed an amateur radio payload before, and all the constraints it has in terms of narrowbandness. So the guys at AMSAT DL gave them all the specifications, and bless them, Mitsubishi designed it, built it. The UAE paid for it. We still have QO-100. It's about halfway through its life now. So it's about 5 years old. We reckon we probably got another 5 years life out of it. But we're not using a spare of any kind on board. It is our payload. They are our transmitters. But the service life of the main satellite is probably 10 years, and we're 5 years into that. It carries, it carries two transponders that I think are on the next slide. Basically, it's a fairly easy way to get into this, because it's on 10 gigahertz. You can use an LNB as you would do for your Sky Dish, etc. They're slightly tweaked because an LNB will drift quite badly on narrowband transmission. It's fine on it. They're much better on digital TV broadcast. So you do tricks like stick a reference signal up one of the coaxes and replace the crystal on board to make it stable. Stabilize usually with a GPS reference clock. Work extremely well. It comes out on about 740 megahertz because you're using an LNB. The ideal solution to that is to stick the 740 megahertz into an SDR and then use a piece of software like SDR Sharp or SDR Console at 750 megahertz, and you can get the audio and the weight and the waterfall out. As I said, the antenna, we have something called a potty. There's a picture of that in a second, called it the patch of the ear, because we're using patchy antennas. You'll transmit left hand from the patch antenna to produce a right hand signal to the satellite. 2.4 gigahertz. Because we're doing an uplink on 2.4, we don't have problems with Wi-Fi reception. My dish is pointing at about 146 degrees in azimuth, and that looks right down the side of the house. If I put it on the side of the house, if I put the antenna up, and I'm probably flattening most of the local Wi-Fi. So it's now in the bottom of the garden, nice and clear, apart from the trees, of course. It's got two radios on board. It's got a narrowband transponder for SSB, 70 sems up, 2 meters down, with some other equipment. I have a pair of commercial transverters. So it comes in on X band down to 70 sems. Up it goes, out on 2 and out on 2.4. I should have actually got an image of those, but I haven't. Or you can use you already know about the Plutos. You can use a Pluto for the reception, or a Lime. Either the American version of the Pluto or the Chinese versions. The Chinese versions work reasonably well. Our colleagues at the British Amateur Television Club have developed a system called Ports Down, which is for the DATV system. Basically, it's a kit of parts which you build. There's something like several hundred of them are built around Europe now extremely well. This is the potty. It's literally a 22 millimeter plumbing pipe with a patch antenna, so a reflector driven element, and the conic thing on the end is a PTFE lens. Some strange dynamics of PTFE and microwaves, and you can actually lens the signal down the pipe. On the end of the pipe, you put the LNB, because spookily enough, 22 millimeters is also the same diameter as most LNBs. So with a 22 millimeter copper coupling, you can attach it to the LNB. Some of our guys in AMSAT UK have made a lot of these. Extremely simple to make. Oops, gone back on this one. Go back. Off-the-shelf equipment. This is the Chinese amp. It's intended for boosting 2.4 signals, but for our use, with a bit of tweaking of one wire inside, it becomes a permanent PA. There are also Chinese rip-off preamps as well. Very wideband, of course. Problem with being wideband, they're also noisy, but they do work. I talked about the wideband system. This is an image of the spectrum of the digital TV. The signal on the left-hand side is the beacon, which has been permanently transmitted. The signals on the right-hand side are amateur radio operators transmitting. We've also got a chat, so a lot of YouTube chat is, hang on, get off my frequency, or I'm going to use this frequency. So there's a lot of video chat. Every Wednesday, I think they have a net on QO-100 with about 15 stations in Europe and down towards South Africa. I mentioned how many satellites are in use at the moment. This is probably about 3 weeks old, I think, maybe a little bit longer. And it gives a visual representation of the number of satellites in use. Left-hand side are the satellite names, and the image basically is over time. And this is people reporting having heard the satellites. Some of these satellites are now extinct. I think this is probably about 30 satellites. And I think active now there are about 18, because as I said before, they do decay, batteries die, solar panels give up, or they just simply deorbit. If it's been launched as a CubeSat from an academic organization, their lifetime is in terms of months. So the typical lifetime of a satellite launch from the ISS is probably about 3 months. Experimental satellites launched on Starlink Getaway specials are in the order of 9 months. Some of them are extremely effective, and now there's a nice turnover of FM satellites. Let's see what the next slide is. I talked about QO-100 being a geostationary satellite. The center point is in the center of South Africa, but it reaches as far north as northern Norway, to the south as far as Antarctica. We actually have a station in Svalbard, in I can't think of it. Anyway, we have a station at the German Antarctic Research Station that has a QO-100 system. So we've worked all the way from Antarctica to northern Norway, just about on the horizon for both stations. If you look on the top left, you can just about see the coast of North America. It's out officially, it's outside the footprint of QO-100. We have actually managed to get a contact outside that footprint, literally at almost 0 degrees. If it could well have been below the horizon, but we got the sea scatter at 10 gigahertz and 2.4 gigahertz, and we spoke from Newfoundland to the United Kingdom. Very, very weak signals, but at least we proved we could actually work from the US. Our US colleagues are not happy because they don't have this facility, because they can't get a ride share that we got on QO-100. There is currently a move within the European Space Agency to do a study to see if there is a viability for launching on an ESA-funded mission. Sorry, ESA are getting involved in defining a mission as a ride share on a geostationary satellite to cover Europe and Canada and parts of the United States. But that's all in the offing at the moment. Lots of sites you can pick up information on where satellites are. On the web, n2yo.com is probably one of the best. There are others, but I can let William know more about that after the conversation. I'm going to stop this one now. Hopefully.
Yeah, I think we're interested in learning as well about the ESA competition.
Yeah, I can talk about. Give me a second. Yeah, just a quick look at what this is. A view of our station at Goonhilly. It's actually tracking the International Space Station at the moment, so it's actually in real time. Let's see if I drop these two. That's our antennas at Goonhilly in real time. Not tracking anything. Well, it's raining in Goonhilly. The coaxes are this afternoon. We're blowing about quite vigorously because we had a gale going on. The other thing that's going on at Goonhilly is we have the tiny GS, which is a tiny little ground station built on a Heltec V3 board. And just in front of the antennas there, if I can see it again, you can just about make out there is a small antenna, which is actually the ground station for Goonhilly for the tiny GS. This ground station is the smallest of the Goonhilly Earth Station by a long margin. We also run a SatNog system. SatNog is a version of ground segment as a service. Something like 70 ground stations around the world coordinating to pick up information. My SatNog station is active all the time. Works extremely well, running on a Raspberry Pi and a FunCube dongle.